Hello, today I will be going through a question taken from Naval Base Secondary School, AMATS Prelim Paper 2022. This is a question on binomial theorem. It says, in the expansion of x squared minus x out of 2m out of 2x bracket power 12, where m is a positive constant, the independent term of x is 126,720. Show that m is equals to 4. So for a question like that, when we have terms, phrases like the term independent of x is, usually we are looking at a specific term in the entire expansion. With that, let's consider the general term. How can we write this expansion? Let me rephrase. How can we find the general term of this expansion? So general term would be written in terms of t subscript r plus 1 equals to 12 choose r. Okay, the 12 is taken basically from the power x squared power 12 minus r minus m over 2x power r. Okay, so from here, we will have to manipulate all the terms such that the non-x terms are grouped together and the x together with its powers are grouped together. So how do we do that? 12 choose r remains as it is. This, what we could do is we could simplify the power, which gives us x to the power of 24 minus 2r. And the other portion here, let's use indices to split up the fraction. Okay. Following this, what else can we do? You have realized that this is x and its power, and this will be x and its power. Let's put these two portions together of the expression, and 12 choose r together with the third portion of the entire expression together. Okay, what happens with 1 out of x to the power of r is that it becomes x to the power of negative r. So in doing so, we apply the laws of indices. When we bring up the denominator to the numerator of a fraction, the power actually changes from positive to negative power. Okay, and therefore, let's tidy up all the terms in the expression. X to the power of 24 minus 3r. Okay, so what I've done is basically I have combined these two portions of the entire expression. Okay. From here, let's move on to the next part. Question says that term independent of x is given. So when we consider term independent of x, means that the power of x must be 0. And where in the general term are we looking at for power of x? Here, this one, okay? This one basically gives you the power of x. So therefore, when we consider independent term of x, means that 24 take away 3r equals to 0. And from here, we could work out our value of r to be 8. Okay, now if the value of r is 8, that means we are considering t r plus 1, which is t9. T9 would be the term where it is independent of x. Okay, and what is its coefficient? Well, the coefficient of that can be taken from this part of the expression. this part of the general term rather. Okay, so I am going to sub the value of r equals to 8 within this portion that I've highlighted green. And this would give you the coefficient 126,720. Okay, now how can we find the value of m? We find the value of m by solving for this. Okay, so let's consider solving this equation now. So 12 choose 8, bracket negative m over 2 power 8 equals to 126,720. Okay. Let's work out the values. That would give us 495 multiplied by 1 out of 256. Okay, that would be negative half to the power of 8. And of course, we have m to the power of 8. And that would give you 126,720. So if I were to divide both sides by the values over here, and I take the 8th root because I have m to the power of 8, I will end up with m equals to 4, shown. So this is the first part of the question. Following that, hence find the coefficient of x to the power of 9 in the expansion of, okay, this entire product of these two terms, two expressions. How do we do that? Okay, it's not as straightforward as we thought it would be. Okay, so question is, are we going to expand each and every term of the first part? X squared minus m over 2x to the power of 12? Not really. Okay, because if we do so, I don't think it justifies the 3 marks. So let us consider in the entire expansion of this first part, okay, let's consider the terms that would multiply with each of the terms within the second bracket, okay, to give a coefficient, to give an x to the power of 9 term. Okay, so let's see. Most likely we will have to consider a rainbow method because when we have an expansion, we will have a series of terms, right? So if we have a series of terms, when something is multiplied by x, 8x to the power of 9, okay, that will give you a coefficient of x to the power of 9. Then what kind of a term is this? You will need to consider an independent term, right? A term that is independent of x. Something that is just a real number. Real number multiplied by a term with x to the power of 9 will give you an x to the power of 9 term. Correct? Now, what else? Another term got to multiply by 5 as we rainbow the terms out to give you an x to the power of 9 term. So this other term that we need to consider would be a term, an x to the power of 9 term. Okay, so we need to consider two separate terms. One here and another here. Okay. Now, we have already found a term that is independent of x. And the term that is independent of x is actually 126,720. Okay, where did we get this value? Well, at the top of the question, for part A, the independent term of x is 126,720. Okay, so I'm using this for part B. because they say hence, right? Find the coefficient. So now what we are left to find is actually the x to the power of 9 term. Okay. Now, if the power is 9, then we will have to say we let 24 take away 3r be equals to 9. Yeah, so let me backtrack a little. Okay, in the general term, see 24 minus 3r is actually the power of x. Okay, so we take 24 minus 3r equals to 9. And from here, we would find the value of r. R is equals to 5. That means the sixth term would actually contain the term of x to the power of 9. So T6, let's find the coefficient. 12, choose 5. Negative half. 4. Okay. Right. If you are wondering where I get the 4 from, 4 is actually the value of m from the previous part. Okay, so after working it out, I would get, okay, so this means that the expansion of x squared minus 4 out of 2x, the power of 12, can be rewritten this way. Okay, so for the first part, I don't need to consider all terms. I just need to consider the term that is independent of x, which is 126,720. And another term, which is negative 25344 x to the power of 9. Okay. And from here, if I were to do rainbow method, only the product of two products from one from each side actually work out to give you x to the power of 9. So coefficient of x to the power of 9 would be formed when we take 126,720 multiplied by 8. Okay, because independent term multiplied by a term that has x to the power of 9 will give you x to the power of 9 term, together with negative 25344 x to the power of 9 multiplied by 5. Okay, so this would give you another term that is that has x to the power of 9 in it. So this will give us 887,040. Yep, so this would be the final answer.